Hi, Assalamualaikum. Let me explain you about the importance of dimensional analysis or what is the uses of dimensional analysis. Alright, so please focus on my explanation. I think we just go through by discussing some example for this, okay? Okay guys, as we know, dimensional analysis is a technique to check the correctness of an equation or to assist in deriving an equation. So the uses of dimensional analysis are, the first one is to determine the unit of any physical quantity. The second function is to determine whether a physical equation is dimensionally correct or not. Okay, by using the principle of dimensional homogeneity. And lastly, we may derive or construct a physical equation or to derive a relationship between different physical quantities. Alright, so remember, three different functions here. Okay, this is the first one, this is the second one, and this is the third one. So you need to understand very well how to use the dimension analysis method for these three different functions. Okay, we just go for it one by discussing some example. Alright, now let's discuss about the first function, which is to determine the unit of any physical quantity. Alright, so let's discuss about this. And let's say by asking you to determine the SI unit of momentum. How is it? Alright, so for this, as we know, the equation of momentum is P equals to mv. By using the dimensional analysis, we know that dimension of momentum equals to dimension of m multiplied by dimension of v. Okay, so we know that m representing mass, so the dimension of mass is capital M, while v now representing the velocity, and the dimension for velocity is lt to the power of negative 1. So from this, we may say that the dimension of momentum is m lt negative 1. So this is the dimension of momentum. Automatically, we know that the unit of momentum equals to m now representing the dimension of mass, where the unit is kilogram. L representing length, so the unit of length is meter. While T representing the dimension of time, so the unit of time is second, so that you will get kilogram meter per second. So this is the way how do we use the dimensional analysis in determining the SI unit of any physical quantity. Okay, next function is to determine whether a physical equation is dimensionally correct or not, which is by using the principle of dimensional homogeneity. Okay, how is it? Alright, let's say by giving you an equation which is V equals to U plus AT. Alright, by having this equation, remember we have two different sides here. Okay, so this is our left hand side, and this is our right hand side. For this method, we need to find the dimension for each side separately, and then we just compare it by getting equal dimension for both sides, so that we may conclude that the equation is dimensionally correct. Or by getting different dimension for both sides, so the equation is wrong. Okay, so how is it? Okay, we just start side by side. So I want to start by the left hand side. So the dimension at the left hand side equals to the dimension of v, which is velocity. So the dimension of velocity is lt to the power of negative 1. Okay, and then we just turn to the right hand side. At the right hand side, we have two different parameters, which is the first one is u. So at the right hand side, we just start by u, dimension of u. So u now representing initial velocity. So its dimension still the same, which is lt to the power of negative 1. At the same time, at the right hand side, we have another parameters here, which is a and t. So the dimension of a and t, wait, something is wrong here. Okay, so a and t. So a representing acceleration. So for any acceleration, the dimension is lt to the power of negative 2. Alright, and t representing the time. So the dimension of time is capital T. So lt to the power of negative 2 multiplied by t, giving you lt negative 1 again. Okay, seems like they are equal to each other. So the dimension at the left hand side equals to the dimension for the right hand side. So as conclusion, the dimension at the left hand side equals to the dimension at the right hand side. So that the equation is dimensionally correct. Settle. See? So remember, in doing this, we need to separate these two sides. Okay? We need to do it side by side lah, because we need to compare it. Okay? Don't forget that. Okay, now the last function of dimensional analysis is to derive or construct a physical equation or to derive a relationship between different physical quantities. Okay, how is it? What does it mean? So let's discuss one more example for this situation. Okay, let's say by giving you a case to be like this. And there is a simple pendulum. Okay, the simple pendulum is shown in figure 1.1. Okay, we don't have to refer any figure here because I think you know already how was the simple pendulum is. Okay, so assuming the period t of the oscillation depends only on the mass, the length L of the thread, and the acceleration g of free fall. Okay, three factors now. Okay, affected the period. Okay, the period not affected by mass, length, and acceleration. So, how is it? Are they directly proportional? Are they inversely proportional? We doesn't know, isn't it? So that we just assume that period now is proportional to, the first one is mass, the second factor is L, the third factor is G. So are they directly proportional or inversely proportional? We doesn't know, so we just put the index number here as X, Y, and Z. Alright, so basically the equation getting now is T equals to K m to the power of x, L to the power of y, and G to the power of z. Okay, so by using the dimension analysis, we know that the dimension for both sides should be equal to each other. So dimension of t equals to the dimension of k equals to the dimension of m to the power of x, and then dimension of L to the power of y, and then multiplied by dimension of G to the power of Z. Okay, so period is under time. The dimension of time is capital T. equals to. K just a constant. Constant is dimensionless, so we know that the dimension equals to 1. M representing mass. The dimension of mass is capital M, so M to the power of X. L representing length. So the dimension of length is capital L. So L to the power of Y. And G is the gravitational acceleration, so that its dimension is LT to the power of negative 2, which is under acceleration. And then to the power of Z. Okay, this one is Z. Alright. So we just expand the equation. You will get T equals to M to the power of X, L to the power of Y, and then L to the power of Z, and then T to the power of negative 2Z. Okay. Okay, now let's continue by the next part. Okay, we may combine these two L because they are equal, so that you will get T equals to M to the power of X, L to the power of Y plus Z, and then T to the power of negative 2Z. Alright, so at the right hand side, what do we have? Just T only. Okay, at the left hand side here, what do we have? Just T only. But at the right hand side, we have three different items now, which is M, L, and T. So in this case, at the left hand side, we still have L and M actually. Alright, so the equation still the same with M to the power of 0, L to the power of 0, T to the power of 1. Okay, which is equals to M to the power of X, L to the power of Y plus Z, and then T to the power of negative 2Z. Alright, so remember, M to the power of 0 still equals to 1. L to the power of 0 still equals to 1. So that 1 times T, you will get T, isn't it? So they are the same actually. Alright, after that, we just compare each items now. M and M, L and L, T and T. So that we just refer to the index number only. For M, what do we have now? 0 equals to X. Okay, we just start by M. Okay, 0 equals to X, or X equals to 0. By comparing L, what do we get? L, we got 0 here, and L here we got Y plus Z. So 0 equals to Y plus Z. Okay, leave it first. By comparing T, what do we get? Okay, for T, we have 1 and negative 2Z. So 1 equals to negative 2Z. So that Z getting out is equals to negative half. Substitute Z into the second equation before. Alright, so 0 equals to Y plus Z, which is negative half. So that you will get Y equals to positive half, isn't it? Alright, so by getting the values of X, Y, and Z, then we just substitute into the main equation before here. Alright, okay, so what do we get now? Okay, I need to erase this one first. Alright, so according to the equation generated before, so that what do we have now? So that T equals to K M to the power of X. X getting before is 0. And then L to the power of Y. What is Y? Y equals to half. And then multiplied by G to the power of Z. Z equals to negative half. Okay, so remember, M to the power of 0 giving you 1. So the equation is K L to the power of half G to the power of negative half. You will get G to the power of half at the bottom here. Alright, so this is T. Still equals to K multiplied by square root of L over G. So this is the equation of period. Okay, so this is the example how do we use the dimensional analysis in deriving any equation. Okay, alright, I think that's all. You may try it by answering all the tutorial question later. Thank you. Assalamualaikum.